roots. Okay? In the past, I said you multiply the 2 and the 18, and then you take the square root and you simplify it. We don't do that if there's negatives involved. Because if I multiply negative 2 times negative 18, I'm going to get positive 16, and I'm just going to say that's 4. Right? Well, but that doesn't account for these two negatives here. So, before you multiply, if you have a negative under the square root, the first thing you do is take out your I. Okay. So then I have I root 2 times I root 8. Then I multiply them together and I get I squared times the square root of 16. If the square root of negative 1 is I squared is negative 1. Does that make sense?
Why would it be negative 1?
Because if the square root of negative 1 is I, square roots and squareds are opposite of each other, right? So if the definition of I is that it's the square root of negative 1. Well, then if I square a square root, I get the thing back that I had to begin with, right? So,
I'm thinking of multiplying a negative and a negative positive.
but that doesn't work with I. So I squared gives me negative 1, and the square root of 16 is 4. So this is negative 4. Okay. If I have 7 times negative, so this is times I root 11. I multiply those together. This is I times the square root of 77. And then 77 doesn't have anything to come out. Oh, sorry. Right there. So the I squared gave me negative 1, and then 16 gives me 4, so it's negative 4. Does that make sense? Yeah. Okay. So this one was nice because it's just one I. Next, negative 5, negative 6. I'm going to take the i's out first. So I have I root 5 times I root 6. And then that gives me I squared times the square root of 30. So 30 doesn't have anything to come out, right? Well, I squared is negative 1. So that's just negative the square root of 30. Okay. I'm going to go into the next topic. No, never mind. I'm going to divide them now. First, I take out the i's. You know how I told you can't have square roots in your denominator? Can't have i's in the denominator either.
Why'd you make the denominator 24?
Oh, I didn't mean to. I meant to make it 6. Thank you for catching that. Okay, so no radicals in the denominator, no i's in the denominator. So in order to cancel the I need to multiply it by I, because I times I is negative 1. So if you square I, you get negative 1. And then to get rid of the square root of 6, I multiply it by the square root of 6. Okay, this I times I is negative 1, right? I squared, negative 1. Square root of 6, square root of 6, so that's 6. Here I have I times I, so that's negative 1. And then a square root of 24, square root of 6, I'm going to be lazy, is the square root of 144, which is 12. So I have negative 12 over negative 6, which is positive 2.
When you multiply a variable like x times x,
Mm-hmm. So first I'm going to pull out my I. That sounds awful, doesn't it? I'm going to pull out my I.
so you keep left and
Okay, I can't have i's in the denominator. I can't have radicals in the denominator. So to get rid of that, I'm going to multiply by I root 10. I times I is negative 1. Root 10 times root 10 is just 10. And then I times I is negative 1, and 30 times 10 is 300. Now 300 has a 100 in it, right? It's 100 times 3, and 100 is a perfect square. 10 times 10. So this is negative 1 times 10 times root 3. Over, now I have negative 10, right? Well, negative 1 times 10 is negative 10. And they cancel each other out, leaving me just with root 3.
Is there a shortcut to that one?
No. It almost, because you think negative 30 divided by negative 10 is positive 3.
Yeah, because that's what it ended up being.
But
It's not always the case.
not, yeah. Okay, no radicals in the denominator. Oops, I forgot to pull out my I. So what this is actually is I times the square root of 66 times root 6 and over 6. And 66 times 6 is 396 over 6. Well, I know that that's 66 times 6, so, which is 6 times 11. And I could keep going, but I have a pair of 6s, don't I? So this is 6i times the square root of 11 over 6. And my 6's cancel. So I end up with I times the square root of 11. Maybe it does work. I was always told no, but it seems like with all of our examples. No, see, look, this doesn't work. Okay, so no, it doesn't work.
Reduce it?
But no, because 24 over 6 is 4.
So
Oh, yeah, it does work, because that's 2.
It does the same thing. If you reduce it.
Okay, see, I was always told it doesn't work. Maybe they lied.
It did in the ones where you're doing now.
Yeah. It's possible they lied.
To make you do the long hand.
Mm-hmm. But I'm, old school.